Hello and welcome to another past paper session. This paper is paper 3, November 23, the variant of the first one. Let's begin solving this. Okay, the first question says find the exact coordinates of the points on the curve y equals to x squared 1 minus 3x at which the gradient of the tangent is equals to 8. So I want to calculate dy by dx. I will have to do a quotient rule. So u dash is 2x, v dash is minus 3. So it's u dash v minus v dash u over v squared. I want to figure out when the gradient is equals to 8. So equals to 8, 6x squared plus 3x squared over 1 minus 6x plus 9x squared. Cross multiplying gives me 8 minus 8 6 is 48 plus 72x squared equals to 2x minus 3x squared. 75x squared minus 50x plus 8 equals to 0. Okay, so A is 75, B is minus 50, and C is 8. So let's solve on our calculators for now. On the exam, you have to make sure that you show me the quadratic formula. 75 minus 50 and 8. So I'm getting x as 2 over 5 and 4 over 15. Okay, and I also want to find the y coordinates, exact coordinates. So y equals to 2/5 squared 1 minus 3 times 2/5. So 0.6, sorry, 0.4 squared over 1 minus 4. I'm getting minus 4 over 5 for x equals to 2 over 5 and 16 over 45 for this. Okay, those are the correct answers. Let's move on to the next question. It says on an Argand diagram, show the region whose points represent the complex number z, satisfying the inequalities this and that. Now, on the exam, you have to make sure that you draw an accurate diagram, and I'm going to try to do as accurate as possible. Okay, so let me mark my axis. First one, so that's 1, 2, 3, 4, 1, 2, 3. Okay, how do I turn this around? So I have 1, 2, 3, 1, 2, 3. Okay. Now, what do I have to draw? I have to draw a perpendicular bisector of 2i and 2 plus I minus 2 plus I. So what points am I talking about? I'm talking about 2i. So that's here. That's the imaginary axis and that's the real one. And I want another minus 2 on the real axis and positive I on this axis. So this is the point that I'm talking about. Then this is the other point that I'm talking about. I need to draw a perpendicular bisector of this and that. Okay. Now, how do I draw the perpendicular bisector on the exam? You'll have to make sure that you draw it with a ruler, with a compass, but right now I don't have that. So I'm going to try to be as accurate as possible, and I will draw it as accurate as possible from here. I don't know if it's still the correct angle. Okay, as long as there's no other part involved, I think I can just make sure that I draw it as accurately as possible. That is my perpendicular bisector. And then it says argument of z plus 1. So my starting point should be -1, and I should draw an angle of 45 degrees. Okay, so -1 and 45 degrees should take me there. Okay, what region do I want? I want the region that's closer to 2i and that has an angle of between 0 and pi over 4. Okay, so between 0 and pi over 4 and closer to 2i. 0. Okay, 0 and 2 over 4. So there's a line at 0 and the angle has to be between pi over 4 and 1. Pi over 4 and 0. Okay, so that is the correct answer. Let's move on to the next one. Question number 3 is, I think, logarithms or linear law. The variables x and y are related by the equation y equals to a b power x, where a and b are constants. The diagram shows the result of plotting L and Y against x for two pairs of values, x and y. The coordinates of these points are this and that. Use this information to find the values of a and b. So if I bring it into the format ln y equals to ln ab power x, I get ln a plus ln b power x, ln a plus x ln b. So I think my gradient should be equals to ln b and my y-intercept should be equals to c. So ln b is equals to y2 minus y1. So the gradient will be y2 minus y1 over x2 minus x1, since these are the 2 points that I have, and they are equal to ln b. Let's solve for b. 6.46, and I have b as 9.97. Let's check if that is the correct answer. Yeah, that is the correct answer. Um, then to find the value of a, there are two things that you could do. You could either use this gradient or sort of join this line and see where it meets c. I am going to do this. So this is about 1.4. So ln a should equal 1.4, and then e power 1.4 should be 4.06. Okay, so a is 4.06. I've taken ln to the other side, it turns into an e power whatever the number is. Question number 4 says the complex number u is defined by this, express u in the Cartesian form where x and y. So it's asking me to simplify this or divide this or rationalize this, whatever you want to call that. I multiplied by a plus 5i and a plus 5i. To rationalize this becomes 3a plus 15i plus 2ai plus 10i squared over a squared minus 5i squared. So I get 3a plus 15i plus 2ai minus 10 over a square minus 25i squared. So I get 3a minus 10 and 15i plus 2ai plus 25. So 3a minus 10 over a square plus 25 plus 15i plus 2ai over a square plus 25. Let's check if those are the correct answers. Yeah, those are the correct answers. Given that argument of u is equals to pi over 4, find the value of a. So argument is basically tan inverse of y over x. It's telling me that it's in the first quadrant, so that tells me that I don't need to worry about negatives and positives. So tan inverse of 15 plus 2a over a square plus 25 divided by 3a minus 10 over a square plus 25 is actually pi over 4. So tan inverse of 15 plus 2a square plus 25 multiplied by a square plus 25 over, so 3a minus 10, and I have equals to pi over 4. So 15 plus 2a over 3a minus 10 should equals to tan of pi over 4. Tan of pi over 4 is 1. So 15 plus 2a over 3a minus 10. 15 plus 2a equals to 3a minus 10. And that should give me 25 equals to a. Okay. Moving on to the next one. It says sine x. There's lots of compound angles, so let's start simplifying. So this is sine x cos pi over 6 plus cos x sine pi over 6 minus, so let's first look at the left hand side because the right hand side is even more complicated. Sine x cos pi over 6 minus cos x sine pi over 6. Okay, so cos pi over 6 is root 3 over 2 sine x plus half cos x minus root 3 over 2 sine x plus half cos x. So this cancels out and gives me cos x. So that's the left hand side. For the right hand side, I'm going to do cos x cos pi over 3 minus sine x sine pi over 3 minus cos x cos pi over 3 plus sine x sine pi over 3. So cos pi over 3 should give me half cos x minus root 3 over 2 sine x minus half cos x. So I get minus root 3 sine x on the right hand side. So left hand side equals to right hand side. I get sine over cos, so minus 1 over root 3 equals to sine x over cos x. Tan x should equal minus 1 over root 3. Is that the correct answer? Yes, that is indeed the correct answer. Okay, you could rationalize it and say root 3 over 3. That would be absolutely fine too. This is hence solved. So tan x equals to minus 1 over root 3. I first draw my quadrants. I am looking for negative tan, so that's in quadrant 2 and quadrant 4. I'm going to calculate my alpha, tan inverse of 1 over root 3. What's tan inverse of 1 over root 3? It's pi over 6. So in quadrant 2, I have x equals to pi minus pi over 6, 5 pi over 6. And quadrant 4, I will have 2 pi minus pi over 6. This is 11 pi over 6. Okay, those are the correct answers. Moving on to question number 6, the parametric equation of a curve are this and that. Obtain a simplified expression. So I'm first going to calculate dx over dt. That's t power half plus 3. So half t half minus 1 plus 0. And dy over dt is 1 over t. Okay, 1 over 2 root t dx over dt. dy over dt is to 1 over t. How do you construct the chain rule? You say you want dy by dx, so dy by dt divided by dx by dt. What's dy by dt? It's 1 over t divided by 1 over 2 root t. So 1 over t divided by 1 over 2 root t. That gives me 2 root 1 over t multiplied by 2 root t. So that's 2 root t over t. Okay, or t power half in the denominator, whichever works. It just is a simplified expression, so that's, I think, simplified enough. I can have another equivalent as well, but that's the final answer. Then it says, hence find the exact coordinates of the point at which the gradient of the normal is -2. So that's dy by dx is the gradient of the tangent, gradient of tangent, gradient of normal will be minus t over 2 root t. Okay, so minus t over 2 root t equals to -2. For root t. So t divided by root t power half gives me 4. So t power 1 minus half gives me 4. So t power half gives me 4. Square both sides. So t equals to 16. Okay, question number 7 says the variables x and y satisfy the differential equation. This it is given that x equals to 1 when theta equals to 0. Solve the differential equation obtaining an expression for x squared in terms of theta. So I'm going to shuffle this around and say that x squared plus 3 dx equals to tan theta d theta. Integrating both sides. On the left hand side, I have integration by recognition, so I'll need a 2 here and a half outside to make sure that the differential of the denominator is present in the numerator. So I get half ln x squared plus 3. And the integral of tan theta is minus ln cos theta. This is something that you should remember. Plus c. Half ln 1 square plus 3 minus ln 0 plus c ln 1 plus c. So I have half ln 4 ln 4 power half. 4 power half is 2, so c is ln 2. So I have half ln x squared plus 3 equals to minus ln cos theta plus ln 2. Ln x squared plus 3 minus 2 ln cos theta plus 2 ln 2. Ln x squared plus 3 So this gives me ln 4 over cos square theta. I hope I'm doing this correctly. Ln x squared plus 3 ln x square plus 3. Okay, let's check if that is the correct answer. Yep, that is the correct answer. Okay, by sketching a suitable pair of graphs, show that the equation has only one root. So the graph of root x looks like this. It starts from 0 and it goes like that. Okay, let's mark 1, 2, 3, 4. At 4, it's at 2. No, don't mark that. Okay, so let's say that's 2. Okay, then 3 e power x minus 3. E power x typically looks like that. In this case, it should move down 3 units. So moving down 3 units gives me 1, 2, and 3. Okay, and then it goes like that. It should have one root. It's one intersection point. Okay, show by calculation that the root is between 1 and 2. So root x minus ex plus 3 becomes the function. I move everything to one side. Then I calculate f of 1, which is the root of 1 minus e power 1 plus 3. That's 1.282 and f of 2. That's minus 2.975. So function goes from negative to positive. Function goes from positive to negative. Root lies between 1 and 2. Okay, show that if a sequence of values given by the iterative formula this converges, then it converges. So I want to prove to you that this is the same equation that is there earlier. So I'm going to remove the subscripts n and I move ln to this side. This becomes this and e power x minus 3. So that's hence proved. Use the iterative formula to construct to find the root. So I'm going to start with x1 equals to 1.5 and I want to show you each iteration to 4 decimal places and the alpha factor. Okay, so x1 is that 1.5. I'm going to do the entire thing on my calculator and that's how you should do it too. 3 plus root of 1, 3 plus root of answer. Okay, so x2 is 1.4410. That approximately rounds off to 1.44. X3 is 1.4352. That rounds off to 1.44. And then X4 is 1.4346. 1.44. Okay, next question. It says the diagram shows a curve with this and its maximum points. How do you find the maximum point? You differentiate and you equate to 0. This is the product rule as I see it. So u equals to x and v equals to e power minus 1 over 4x square. U dash is 1 and v dash is e power minus 1 over 4x square into minus 2 over 4x, differentiating the function on the top. So dy by dx is basically u dash v plus v dash u over 4x. So figuring out the common is important. 1 minus 2 over 4x squared. Either this equals to 0 or that equals to 0. Half. So 1 equals to half x squared. So x squared equals to 2 and x is therefore equals to root of 2. Let's verify that is the correct answer. Okay, sorry, this rounded off to 1.43, not 1.44, so I'm going to have to do another iteration, I think. And this gives me 1.4345, 1.43. Okay, sorry for that. X equals to root of 2. Let's check if that is the correct value. Yes, that is the correct value. So I go back and find out the y coordinate. Y equals to root of 2 e power minus 1 over 4 root of 2 squared. So root of 2 e power minus half. So root of 2 and root of 2 e power minus half. Using the substitution x equals to u, root of u, or otherwise find the integration, the exact area of the bounded by the curve, the x-axis, and the line x equals to 3. So let's first write our expression for the area. It's going to be x e power minus 1 over 4x squared dx. What is the substitution that we have? X equals to root of u. So let's also differentiate. Dx over du will give me half u power minus half. Okay, so root of u e power minus 1 over, so minus 1 over 4 root u squared. Okay, and dx can get replaced with 1 over 2 root u du. So 1 over 2 root u du. Let's see if something cancels out. Yes, it does cancel out. This also cancels out. So I get e power minus u over 4 du and divided by 2. The limits also have to change. X equals to root of u. So the limit was 0. So use 0 and then root of u. 3 equals to root of u. So u is 9. So 0 to 9. Then integrating this gives me e power minus u over 4 divided by 2 into minus 1 over 4 and with the limits 0 to 9. That's 4. So I get minus 2 e power minus 9 over 4 minus minus 2 e power 0. Looks like a weird answer. Let's check if we're getting that right. Yeah, signs of that right. 2 minus 2 e power minus 9 over 4. Question number 10 is about partial fractions. It's the case with the repeated factor. So let's start doing that. I will have 3 partial fractions: a over 1 minus 2x, b over 2 plus x, and c over 2 plus x whole square. So a gets multiplied with 2 plus x whole square, b 1 minus 2x, and c gets multiplied 1 minus 2x and then another 2 plus x, and then c gets multiplied with just 1 minus 2x. So equating this bracket to 0 gives me x equals to 0, x equals to 2 minus 2 to make this bracket 0. So I'm going to do 24 times 24x plus 13 here. 24 times minus 2 plus 13, a into 0 plus b into 1 minus 2 times 2 plus 0 plus c into 1 minus 2 times minus 2. So minus 48 plus 13 gives me 35, and I have 5c, so c is equals to 7. Then for the next one, I should take the other bracket equals to 0. X equals to half 24 power half plus 13. Okay, so that's 25, and that is 5 over 2 squared, so 25 over 4. So a comes out as 4. Now again, for the said one, I can take any value for x. Let's take 0. So 24 into 0 plus 13, a 2 squared plus b 1 and 2, c into 1. I have a and c, so 4 into 4 plus b into 2 plus 7 into 1, and I have 13 here. 13, 16 plus 7 plus 2b. Okay, so 16 plus 7 is 23. I get minus 10 here. 2b, b is equals to minus 10 divided by 2 is minus 5. Let's see if we have the partial fractions correct. I have 4 minus 7. Do I have minus 7? I should have minus 7. Okay, I don't have minus 7, so let's fix that. So 16 minus 7 is 9, 13 minus 9 is so b is equals to 2 as well. Okay, so the partial fractions are 4 over 1 minus 2x plus 2 over 2 plus x minus 7 over 2 plus x whole square. It says obtain an expansion for ascending powers of x up to and including the term in x squared. Okay, so for 1 minus 2x power minus 1 plus 2 to plus x power minus 1 and minus 7 to plus x minus. Okay, so for the first bracket, I need the first three terms. So term number 1 is a power n, term number 2 is n a n minus 1 b power 1, term number 3 is n n minus 1 over 2 factorial 1 power n minus 2 and minus 2x power 2. That comes out as 1, that comes out as 2x, and that comes out as 4x squared. Okay, so 2 power minus 1 term number 2 minus 1 2 power minus 1 minus 1 x power 1. Term number 3 is minus 1 minus 1 minus 1 over 2 factorial 2 power minus 1 minus 2 x power 2. So half minus 1 over 4x and 1 over 8x squared. N minus 2 n 2 power n minus 1 x power 1 n minus 1 over 2 factorial a power n minus 2 and x power. So 1/4. 3 and 16. 3 over 16 x squared. 1 plus 2x plus 4x squared plus 2 times half minus 1/4 x plus 1/8 x squared minus 7 1/4 minus 2 over 8, that's also 1/4, and 3 over 16 x squared. 4 plus 8x plus 16x squared 2 minus 1 minus half x plus 1/4 x squared minus 7 over 4 plus 7 over 4x minus 21 over 16x squared. Okay, 4 plus 1 minus 7 over 4. 13 over 4, 8 minus half plus 7 over 4, 37 over 4 plus 16 plus 25 minus 239 over 16. I have the answers. Let's verify if they are the correct answers. Or if I made a mistake. 13 over 4, 37 over 4, and 239 over 16. Yes, those are the correct answers. State the set of values of x for which the expansion in B is valid. So remember that for the expansion to be valid, you have to make sure that you check every bracket. So for this bracket, um, the expansion will be valid for modulus of x is less than half. If some other expression is more restrictive, so the other expression would be is less than 2 over 1 for the second bracket, but this is more restrictive, so this is the answer for this part. Why? Because each expansion will have its own range of validity. The first has the range of validity modulus of x is less than half, the second has the range of validity modulus of x is less than 2 over 1, and the third also has that range of validity, but whichever one is more restrictive will apply to all three. Moving on to the last question, this is in the diagram OA, B, C, D, E, F, G. OA equals to this, vector is this, M is the midpoint of EF. Find the position vector of M. So I want to travel from O to M. So I'm going to go 3I, 2J, okay, that OC is 2 and OD is 2 as well. So 2J and 1K. So that's OM. The position vector is this. Calculate angle PAM. So cos theta equals to AP dot AM divided by mod of AP and mod of AM. Do I have AP and AM? No, I don't have AP and AM. Let's see if I can go from A to P. A to P, P isn't plotted here. I just have OP, so I'm going to use that. OP minus OA. OP is 112 and OA is 3I. Okay, minus 212 AM. OM minus OA. I have I can just write 2J and K for that. 0, 2J and 2 and K, 1K. I can see AM on my diagram. So it's A plus M, A and M. Okay, so that's 0 to 1 root of minus 2 squared, 1 squared, 2 squared into root of 0 squared, 2 squared plus 1 squared plus 2 plus 2. 449 and 5. Okay, so cos theta equals to 4 over root of 45. Let's see if we get theta correct. So I'm getting 53.4 degrees. Let's check if that is the correct answer. Yes, that is indeed the correct answer. Let's see, find the exact length of the perpendicular from P. So P is 1, 1 and 2 to the line passing through OM. So a line passing through OM would have the directional vector of OM, which is 3, 2 and 1. And it's going to have the equation 0, 0, 0 plus 3 lambda times 3, 2, 1. So any general point on that line will have 3 lambda, 2 lambda, or 1 lambda. So this point x can be called 3 lambda, 2 lambda, and lambda. So Px will be perpendicular to OM. Px is OX minus OP, so 3 lambda. 3, 2. 9 lambda minus 3 plus 4 lambda minus 2 plus lambda. 14 lambda minus 7. So lambda is half. We want to find the length of the perpendicular, so the magnitude of px, that's going to be 3 into half minus 1 squared plus 2 into half minus 1 squared. Zero and 0.25. Root 2 over 2. Okay, so there's a small mistake here. That gives me 0.5 squared plus 0 squared plus 1.5 squared. And that gives me root 10 over 2. That is the end of the exam, and I will see you with another recorded video in the next lecture.